Okay, hello and good morning. This is MCR. This is week 2, second marking period, and this goes at the bottom. Make sure you put your name, date, and period on your bell work. Okay, in fact, all your work. Look here, function. A function, what is a function? A function is where every domain has only one y. So x has only one y. Okay, if you have x equal to 2 y's, then this would not be a function. Okay, it's a one-to-one. And why is a function important? Because you can write a mathematical equation. All right. Look at these here. Are they functions? Well, 2 has a 3. That's okay. 4 has a -7. That's okay. This one's yes. Is this a function? 2 has a 3. 4 has a -7, but 2 also has a 4. This one is not a function. Okay, this domain has 2 y's. Okay, 2 ranges. Okay, name the domain and range of 2b. Well, the domain for 2b right here is going to be all your x's. 2 and 4. 2 and 4. And your ranges is going to be all your y's. 3, -7, and 4. Okay? X's, y's. Real simple. On a new sheet of paper, draw this diagram. Are these functions? This one is no. It fails the vertical line test. This one is yes. No. Yes. If it hits 2 points, then it is not a function. All right, copy these down. Now look, there's 2 things going on here. This one says take the function and set it equal to 0. So here's your function. So you're going to say 2x minus 3 equals 0. That's type 1. So here you're going to solve this by adding 3 and then dividing by 2. So you get x equals 1.5. So if you put 1.5 here, you're going to get 0. The other one is where you put f of x, where you put a 3 right here for the x. So 2 times 3 is 6, and 6 minus 3 is 3. So you got 2 types. One where you set the function equal to 0, and one where you substitute for the x. This one says find the domain. In this one right here, you cannot have a 0 in a denominator. So you're going to take x minus 4 and set it equal to 0. You're going to get x equals 4. If x is equal to 4, then you get 0, because 4 minus 4 is 0, and that's undefined. So you can't have a 4. So the domain will be all real numbers. All numbers work, but not 4. Okay, you cannot have 4. Today's work is right here. If you have questions, ask. And by the way, we're shooting for a test probably next Friday. Make sure you tell your parents, okay? Let's go to geometry. Geometry here, we're going to extract roots. So let's see about that. Well, you got to break it down by 2's. So 2 times 30, 2 times 15, and then 3 times 5. So you have 2 times 2, that's a perfect square, that's 4. These have to stay. So it's going to be the square root of 4 times 15. The square root of 4 is 2. So the answer is 2 square root of 15. Okay, that's how you extract. This one's a bunch of 2's. That's 2 times 50. And then 2 times 25. But 25 is a perfect square, and so is this one. That's 4. So that's going to be 4 times 25. The square root of 4 is 2. The square root of 25 is 5. So there's nothing left. And 2 times 5 is 10. The square root of 100 is 10. 10 times 10 is 100. Yeah, I guess we should have known that, huh? But here's how you do it mathematically. All right, let's go on. Today's worksheet, you're going to have to do Pythagorean's theorem, and you need it on the ELC. So look up here. First thing I want you to do is color the box. Write that down. All right, try these right now. Well, color this box. These go together. So it's going to be 5 squared plus 7 squared equals x squared. The hypotenuse goes by itself. So that's 25. 7 times 7 is 49. Now to get rid of that square, you're going to do something called the square root. So clear your calculator. And by Friday, calculators should be on desk as soon as you walk in. So 25 plus 49, press equals, and then hit shift, square root. Make sure you can do that. So 8.6 is what we're going to say. This one right here, we're going to color the box. These go together, the ones that are hitting the box right here. So it's going to be x squared plus 4 squared equals 12 squared. X squared plus 16, and this is 144, 12 times 12. Subtract 16. So you're going to get x equals the square root of whatever that is. So 144 minus 16, I get 128, and then I hit shift square root, and I get 11.3. Okay, make sure you can do that. That's part 2 on your worksheet. And by the way, before I go any further, you have a test on Tuesday. Chapter 4. Write that down and tell your parents. All right, let's go on. Ways to prove triangles congruent. There's 4 of them. Side, 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 angle, side, angle, angle, side, and side, angle, angle, side, angle. Okay, those are the 4. Write them down. They're on the board as well. Okay, make sure you know all 4 of those. All right, let's keep moving. There's 2 things you're going to look for on your worksheet today. Always. You always look for reflexive. So this side right here, you're trying to prove that triangle is congruent to that one. This side is reflexive. It's equal to itself. Now, what I'm looking at is side, side, angle. There's no side, side, angle. Angle, side, side. There's no angle, side, side. This one is not congruent. Let's try another one. Another thing you always look for is vertical. This angle right here is right across. They're equal. So this one is angle, side, angle. Angle, side, angle. So this one's yes. Angle, side, angle. On today's worksheet, it's right here. Okay, you're proving triangles congruent. Here they are up here. Make sure you look for reflexive. Make sure you look for vertical. All right. Part 2 is Pythagorean's theorem. I want to see the work. And then finally, on the back side here, same thing. Reflexive, reflexive. All right. And then Pythagorean's theorem. Let me see what this says. Is this angle side angle? That's what they want to know. Well, this is equal to itself by reflexive. So we do have an angle. We do have a side, but we would need another angle here. So they're asking what additional information. So you need this angle here, and you need this angle here. So you got to say it. Angle D-U-T. D-U-T. And then you need this one, which is S-U-T. Those are the 2 things you need. Watch again. This one is reflexive. Okay, right here. So what else do you need for side, angle, side? Well, this is a side. This is an angle. You need this side here. So you need XK congruent to this one right here. Side, angle, side. To WV. Well, XK, it would be VW. Okay, there it is. So you're looking for what additional information will prove it congruent by these ways. Okay? And then don't forget Pythagorean's theorem. I'll see you in class.